Hello students, today we are going to see the next point from chapter 1st, 11 Science. The name of that is Units and Measurement. In this chapter, there is errors in measurement. That means which measurements we are going to take of any physical quantity, there should be errors. So which types of errors and how to minimize them. This is in this point. So there are types of errors and why they happens. There are some reasons which we are going to see now. So why there are errors in measurements? These measurements of physical quantity can be, there should be errors, and these errors are due to the following reasons. From that, first one is there, that is systematic error, or the error consists, first one, that is nothing but systematic error. Why it happens? It happens due to the inaccuracy, or this inaccuracy introduced in an experiment, or due to the measurement of an observer and the observations or the measurement process. So such type of errors are called as systematic error. That means systematically they happens in the measurement, or they are always present in the measurement systematically. So this is called as systematic error. And also it happens due to the imperfect calibration of the instrument. That means that instrument should not be calibrated well, then at that time there should be the error. Also imperfect method of observation. That means what? Observations which we have to take, that should not be taken with the proper method, then there should be the errors, and such type of errors are called as systematic error. Okay. These errors should be positive or negative, and such errors should be minimized by using proper instrument, by taking number of observations. Okay. So from that also first one is there, that is instrumental error. From this first one is instrumental. Instrumental errors. Due to the instrument, that means, for example, thermometer. Thermometer, if it is not exactly or proper zero should not be placed at the properly. Then that time which reading we are going to take, that should not be clear. So this is due to the instrumental error. Also an ammeter. An ammeter is not parted exactly at 0, but there should be the reading, that is 0.5 ampere. It is the reading when we are going to take that ammeter for measuring the current. Then that error is also instrumental error. Then also in case of balancing weight, where we are going to take the balance of some substance, if it is not exactly at the 0 position, then that weight should not be clear, and such type of errors are due to the instrument. So it is called as instrumental error. That means this type of errors arises due to defective calibration of an instrument. So these type of errors are called as instrumental error. Then another second one is there, that error due to imperfection in experimental technique. Imperfection in experimental technique. Which technique you are using for measuring? If it is not correct, then that time there are some defects, some errors. Okay, and in such cases, for example, we are taking the volume of liquid which is in capillary, or which is in suppose in capillary. If it is not exactly in straightly, then that time that volume is not accurate. Then in such cases there is imperfections. Or if we are not measuring exactly time, when there is the oscillation by simple pendulum, then we cannot measure the periodic time of simple pendulum. If you not start the stopwatch at exact time, okay, such type of errors are due to the experimental technique. If we are measuring the length by using ruler, then that time we have to see from the upward towards it, then that time it should be accurate, otherwise no. Such type of errors are called as instrumental error. Then third one, errors due to personal error. Third one is that is personal error. Personal errors. How it happens? Those are due to the person, and this error changes person to person. Such errors are introduced due to fault of observer, okay, or lot of times this error is due to the person. If person have some defect itself, then that time also there is the errors in the measurement, okay. So such type of errors are present while taking the measurement of physical quantity. Then another one, this all errors should be minimized. How it is? It should be minimized by using the number of instruments. That means by changing the instruments, by taking number of observations and this way. Okay. The next one, the another type of error is there. That is the random error. If random errors, how they happen? If we minimize these all errors, still there should be error, and such type of errors are called as a random errors. Type of error should be positive or negative. These type of errors cannot be eliminated completely, but we can minimize them by repeated observations and then taking the mean of them. So how to find out them? For that purpose there is estimation of errors. Estimation of errors. That means we have to take number of observations. By taking mean of them, we will get the exact value of that observation. For that purpose, estimation of errors. And first one, that is mean value. How to find out it? Suppose there are n observations. For example, A1, A2, A3 up to say An are number of observations. Number of observations taken by the observer. Okay. Then how to find out mean of them? Then it is A mean is equal to A1 plus A2 plus A3 plus An divided by n. It is its mean value. Therefore, we can take the mean by using this. Afterwards, A mean is equal to summation A1 to An. That means suppose Ai, which going from I is equal to 1 to n. How many times? N times. So it is 1 upon n summation I going from 1 to n Ai. This can be written in this way also. A mean is equal to summation I going from 1 to n or 1 upon n summation of I going from 1 to n A I. This is equation number first. That is A mean. Afterwards, absolute error. How can we find out it? ABSOLUT. First one mean value, second one absolute error. The difference in between mean value and each individual value, it gives us absolute error. That means what? Or the magnitude of difference in between mean value and each individual value gives us absolute error. That means what? Delta A1, which is equal to mod of AM minus AI. This gives us absolute value of AI. Or delta A2, which is equal to A mean minus A2. Since A delta AN, which is equal to A mean minus A, okay, this gives us absolute error. Magnitude of difference in between mean value and each individual value. After that, mean absolute error. Take the mean of all this absolute error, will get mean absolute error. Therefore, delta A mean is equal to, which is equal to delta A1 plus delta A2 plus delta AN up to divided by n. Okay, which can be written in this way, that is equal to 1 upon n summation of delta AI, delta AI, where I going from 1 to n. So this is delta AN, or it can be given by this absolute error of mean. It is nothing but mean absolute error. It is called as mean absolute error. This is equation number first. This is equation number second. We got A mean absolute error, and after that mean absolute error. Okay. Then physical quantity can be given by A is equal to measured value, can be given by value A, can be given by A mean plus or minus delta A. That means A is equal to A mean. If it is plus, or it should be A mean minus delta A, absolute value. Therefore, the exact or measured value A is equal to A mean plus or minus delta A, or absolute error. Okay, it is in between these two. Therefore, the ratio of mean absolute error to the arithmetic mean is given by relative error. Next, one more point, that is nothing but third one, relative error. Relative error. How it can be related? That means relative error is equal to delta A mean divided by A mean, arithmetic mean. Absolute error mean divided by arithmetic mean, which is given by relative error. So, this error can be found out with the help of the ratio of absolute error mean to the arithmetic mean. And the last one more, when we are going to find out the percentage error, then percentage error, then that time this is equal to delta A mean to the arithmetic mean into 100. Then this error which is converted in percentage error. Okay, these all are the errors which should be introduced while taking the measurement. Okay, thank you.